Algebra, Unit 8, Lesson 7, Note 7, Factoring Completely. When factoring completely, you must always begin with factoring out a GCF. We've been saying that throughout the whole unit. Oh, let me fix that. And it still holds true. Okay? You always must look for that GCF. From there, you can determine which method to use. Dots, trinomials, which I call MAM, or grouping. Keep in mind that once you perform one method, you must check again to see if you can factor the polynomial further. You must factor until you can't factor anymore. Now, these are the type of questions we will see on the Regents factoring questions. It's not just going to, the Regents exam isn't going to say, oh, factor this by using the difference of two perfect squares. It's literally going to say factor completely, which kind of gives you a hint in that there's probably more than one factoring step to take, okay? So be aware of that. Factor completely means you're probably factoring multiple times, okay? We start with our GCF, and then we take a look and see, is it a trinomial or is it a binomial, trinomial, or four terms? And then we can determine, are we going to use dots? Can we use dots? Are we going to factor out the trinomial? Can we use MAM? Or are we going to use grouping? Okay, so always start with the GCF. We're going to do a few of these together, and then you're on your own. Factor each polynomial completely. If it can't be factored, write prime or cannot be factored. Let's start with letter A. So the first thing I'm going to look for is a greatest common factor. Do I have a greatest common factor? Well, each of my terms are even, so I would say I do. I can pull out a 2. When I factor out that 2, I'm left with x squared minus 4x minus 12. Okay, but I'm not done. I'm left with a trinomial inside those parentheses. Well, I can't use dots because that refers to 2 terms, and I have 3. Let's see, can I use MAM? Can I factor the trinomial? I have a coefficient, a leading coefficient of 1. I'm going to go ahead and use my MAM method here. The M is negative 12, and the A is negative 4. Okay, I can do negative 6 and positive 2, which do add to be negative 4. Because the leading coefficient inside those parentheses is 1, I can just factor by MAM. I don't have to split the middle term or anything fancy. So I'm going to carry down the 2. And then I have x minus 6 and x plus 2. Look at each new term. Can I do anything with the 2? No, of course not. It's just a 2. X minus 6, it's a binomial, but I don't have perfect squares. X plus 2, I don't have perfect squares or a difference. So I'm done. And I have factored completely. I did 2 different things, GCF and MAM. Let's look at letter B. GCF. I have a lot of x's in here. I can pull out x to the third. Always pull out your smallest exponent, your variable with your smallest exponent. I'm left with x squared minus 25. I can't do anything with x to the third, but look on the inside, x squared minus 25. I have a binomial, so I need to check, is it a difference? Yes, it's subtraction. Are x squared and 25 perfect squares? Yes. Any variable with an exponent that's even is a perfect square. I'll say that again. If your variable has an even exponent, it's a perfect square. Okay, so bring down your x to the third. And difference of 2 perfect squares, the square root of x squared is x to the first, and the square root of 25 is 5. Make 1 plus, 1 minus. Look at each of these terms. I have a binomial, but it's not a difference, and neither are perfect squares. Here, I do have a difference, but they are not perfect squares. Therefore, I have factored completely. Let's jump down to letter F. Okay, a couple variables in this one. It looks like they have at least one x in common and a y in common. So I will pull out x and y. Again, checking for GCF, always. I have 4 minus, and I have 2 x's left, so x squared. Can't do anything with xy, but I do have a binomial. It is difference, it is subtraction, and 4 and x squared are perfect squares. So carry down your xy. Remember, you have to keep your first term first and your last term last. So meaning I need to do the square root of 4 first. The square root of 4 is 2, so I write 2 and 2 first. The square root of x squared is x, so those will be my last terms. Make one addition, make one subtraction. I can't do anything with 2 plus x or 2 minus x. Therefore, I have factored completely. Let's step it up a notch. Let's look at letter H. I have 4 terms. I'm going to find a GCF first, or look for a GCF. I have 63, 54, 105, and 90. They're not all even, so I know 2 can't go into them. 3. The trick with 3, if you don't know it already, is you can add the digits together in a number, and if it's a multiple of 3, it's divisible by 3. Here's what I mean. So I have 63. So this is a side note. You don't need to write this down. If I add 6 plus 3 together, I get 9. If I add 5 plus 4 together, I get 9 again. If I add 1 plus 0 plus 5, I get 6. And if I add 9 plus 0, I get 9. And if you look at these results, it looks like I have 3 9s and a 6. They are each divisible by 3. So that tells me right there that I can pull out a 3. Just a little divisibility trick. Or you can just guess and check on your calculator or use the GCF function on your calculator. But remember, you can only put in 2 numbers at a time when you're finding GCF on a calculator. Okay, so I'm going to pull out a 3 here. No variables are in common. Actually, I'm going to change this to brackets here. I'm going to have lots of parentheses going on. I have 21n to the third. Again, I'm dividing everything by 3, plus 18n squared, minus 35n, minus 30. Look at the inside. There's no other GCF between 21, 18, 35, and 30, so I'm good there. But I do have 4 terms, so we need to at least attempt to factor by grouping. So I'm going to throw parentheses and group my terms. We're going to leave this 3 on the outside alone, but bring it back in our final answer. 21n to the third and 18n squared. They have a 3n squared in common, which means I'm left with 7n plus 6. Over here, on the next one, notice I have a plus in my common term and a minus here, which means I know I'm going to have to pull out a negative. So I'm going to start by writing a negative or a minus sign. Well, 35 and 30 have a 5 in common. That's the greatest common factor. So when I pull out negative 5, I'm left with 7n plus 6, which is exactly what we wanted. Write your common binomial. You can write it first or second, doesn't matter. And the leftovers. Hope you didn't forget about that 3 from the beginning. Bring that down. We still need to check each term. We can't just assume we're done. 7n and 6, no GCF, not a difference, we're not perfect squares. 3n squared minus 5, it is a difference, and n squared is a perfect square, but 3 and 5 aren't. So I am done. Letter I. Always start with GCF. They clearly both have an 8 in common. I'm going to pull it out. X to the 12th minus 1. Don't forget to put that minus 1. It doesn't just go away. 8 divided by 8 is 1. You must put it in if it's the only thing left. Remember what I said earlier. A variable with an even exponent is a perfect square. And 1, of course, is a perfect square, and we do have a difference. When you're finding the perfect square, with variables and exponents, you just divide it in half, the exponent. So I'm going to bring down the 8 from the outside, and this is going to be x to the 6th and x to the 6th. 1 and 1, make 1 plus, make 1 subtraction. Okay, 8 I can't do anything with. This is an addition symbol, so it's not a difference. There's no GCF, nothing. Moving on. This is a difference. 1 is a perfect square. X to the 6th is a perfect square. Variables with even exponents are perfect squares. So I'm going to start by bringing down these first two terms because I can't do anything with them, so I'm just going to bring them along to my final answer. And this one this last term I'm going to split. X to the 6th, the square root of it is x to the 3rd. And the square root of 1 is 1. Make 1 addition, make 1 subtraction. Check again. I know these first two terms are safe because I couldn't do anything before. The next term, the third term, is addition. Can't do anything with it. This next term is subtraction. 1 is a perfect square. However, x to the 3rd is not. It is no longer an even exponent, which means it is factored completely. Let's look at J. First, we need to check for GCF. Well, they're all even, so I know we can pull out a 2. They all have an A, so I know I can pull out an A. I don't think I can pull anything else out. 10, the factors are 1, 2, 5, and 10. And 5 and 10 don't go into the other two. So 2 is definitely the greatest common factor. 2A, I should say, is the greatest common factor. On the inside, I'm left with 5b squared minus 16b plus 3. I have a trinomial, so I need to attempt MAM. And our leading coefficient isn't 1, so my goal here is to see if I can split the middle term. M is 15, A is negative 16. Well, I have 1 times 15, which gives me positive 16, so I know I have to go to negatives. Negative 1 times negative 15 is also positive 15, but the sum is negative 16. Again, the leading coefficient isn't 1, which means I need to split the middle term. So I'm going to leave this 2a alone for now and just bring it to my final answer. Don't forget about it. 5b squared. My middle term I'm going to split into negative 1b and negative 15b and bring down the 3. And now we do our factor by grouping. The only thing in common in the first grouping is b. I'm left with 5b minus 1. In the next grouping, I know I have to pull out a negative because I have a minus sign here and I need a minus sign there, so definitely a negative. And they have a 3 in common. So this would be 5b minus 1. 5b minus 1 is in common. My leftovers are b minus 3. And remember to bring down that 2a. Now check each term. 2a I can't do anything with. 5b minus 1, they're not perfect. Well, 5b isn't a perfect square. And b and 3 aren't perfect squares. Therefore, it is factored completely. Okay, I'm going to give you a couple little hints, but the rest you're on your own. So I want you to first take a look at letter L. L is a little tricky. I will tell you that you need to pull out a GCF, and it's not a big GCF, okay? When you pull out that GCF, you'll then be able to factor by grouping for that one. Letter M, oops. I will tell you that 6,561 is a perfect square. If you're not sure, personally, I didn't know at first, type it in your calculator. Find the square root of 6561. Okay, if it works, it's a perfect square. If it doesn't, you're done. Okay, so don't give up on this. Okay, and the rest you should be pretty good on.